Hello, my name is Ashley, and today I am going to be showing you how to do an engineering craft. Engineering, a noun, is the study of using scientific principles to design and build machines, structures, and other things, including bridges, roads, vehicles, and buildings. There's chemical engineering, there's genetic engineering, there's electrical engineering, and there's structural engineering, which is something that we will be experimenting with today. Now that you know what engineering is, which I'm sure most of you probably already knew, we can go ahead with my craft. And I want to apologize for my terrible handwriting and my cheesy pictures, but I thought it would be fun. We are going to be making a structure out of toothpicks and marshmallows. Now, if you want to do this at home, you can also use toothpicks and marshmallows. I've seen people, instead of toothpicks, they've used spaghetti noodles and uncooked, of course. And then you can also, instead of mini marshmallows, you could use the candy pumpkins you get with the candy corn packs. There are several things that you can use. Just something that's soft but still sturdy, so that you can start experimenting and seeing what you can build, how tall you can build it, how crazy you can build it. So I'm going to show you what I've got going on so far. This is something that I've already built, just to give you an idea of what we're doing. I'm going to put it to the side and start anew so that you can also see. So I've got a bunch of toothpicks. I'm making a mess already. Okay, so I've got toothpicks, I've got marshmallows. If you want to eat your candy after you do this, please, 1, wash your hands before you do this. 2, make sure you're doing this on an extremely clean surface. And 3, don't share with anybody since you're touching. I don't want anybody getting sick trying to do this, okay? So just be careful with how you plan on eating your candy and how you handle it. Okay, so the first thing I did to make this little square or cube is I just got some of the marshmallows and I just inserted a toothpick to each one. Some of the marshmallows you'll come across are kind of like this one. It's kind of flat, and you can just throw that aside, eat it later, whatever. And so now I've got 4 of these. I want to connect them at the bottom. So I'm going to take a toothpick and just insert into those. And I've got that. And it's not going to want to stand up right away. It might not. That's the point of structural engineering. You have to find out how the components of what you're building come together to create a sturdy structure. Oftentimes, you start with, when you see videos of people making skyscrapers and things, you see all that metal, what I would call its bones. The interior or the integral structure of the building. They start with that inner, most important part that is going to hold the building up. And they make sure that that is the most sturdy part, because that's what's going to keep that building from coming down. All right, so now that I have these connected, I'm going to add a marshmallow to the top. Okay. Now you're going to take some of your toothpicks. Oops. Y'all know I'd be making a mess. I always do. And you're going to connect the upper marshmallows. And be careful when you're using toothpicks. They might not seem like they can cause harm, but if you aren't careful, you can hurt yourself, or at least get a splinter, and we don't want that. And also, if you're going to use your toothpick and eat the marshmallow off of it, please be careful when you put it in your mouth. I know that toothpicks are generally used to get things out between our teeth, but you should still be careful. All right, so now that I have my structure looking like the one I've already made, I'm going to connect these two structures. Let's see if I can do that. This is all about experiment, and you don't have to have something that is so square like mine. You can try a more, let's see, more of a loosey-goosey shape, if you will. Something that's not as geometric, something that's more organic. So I'm going to turn it on its side to help me out a little bit. And sometimes when buildings are being constructed, or when components of buildings are being constructed, they're constructed in another place and brought to the general area of where this structure is going to be located, which is what I'm doing. Before I stand it upright, I put them together. So now I'm going to stand it upright, and it's looking a little wobbly, guys. I got 3 structures here, 3 floors. It's standing, but it's very wobbly. One good thing about structures with these light material, like if this were a building, let's say in Los Angeles, they would want this structure to be able to move. And the reason is because the area is prone to earthquakes. They need the buildings to be able to move but not fall apart. So you could shake it or shake your table and see how good your structure is. You would say, oh, okay, well, this building is going to stand up because it is engineered that way. So I've got that going on. Let's see if I can add another side to it. All right, let's see how it goes. Oh, it's still standing. Woohoo, guys, I did it. I'm going to experiment. Let's see if I can make a slanted roof. Oh, maybe not. Maybe a slanted structure is not a good idea. But let's see if I can make a roof up here at the top. Okay, so I'm going to try to make a little roof. Now you have to put these in at an angle so that they will stay. Alright, let's find us some marshmallow that all of these will go into. I don't know, it's kind of scaring me. Well, my structure is still standing. I am very surprised. It's very leaning. So maybe I can try to build a back part onto this. Make sure that you don't do what I just did. The marshmallows that are at the bottom, the flat side needs to go facing down. That way, it'll have a flatter surface to sit on. Marshmallows in general are a pretty squishy thing, so it won't be too bad. Oh no. This one's not wanting to stay. Well, if we get some more into here. Y'all think I can make this any better? Now, if you all try to do this yourself, please share either on our Instagram, our Facebook page. You can go directly to our Facebook page, and you can post onto our page. That way we can see all your creations. All right. Let's see if I can build another tower on this side. Be very delicate with my voice and everything. That would be something interesting to research. If noise, if sound waves can impact a structure, can impact a building. It was just the 20th anniversary, if you can call it an anniversary, it really doesn't feel like one, of the 9/11 terrorist attacks. And from that, they decided to build a new trade center. That trade center that they built is 1,776 feet tall. And if you don't know the significance of that, let me tell you. That is the year that we associate with our independence, America, the United States. So it's neat to me that they, out of that scary and horrible moment, we built something beautiful and that has a lot of meaning. And there is a great documentary on PBS or KET about how they built that, and that would be a great video that you and your family could watch together and see how they went about building that. And then maybe one day if you ever get to go to New York City, you can go and look at it. It's a very remarkable building, not just because it's structurally amazing, but because it has a lot of meaning. Okay, so let's try this one. Oh, I'm so nervous. Oh goodness, look at this. Look at my structure. All right, I'm gonna stop here for the sake of not having a super long video. But you can see that my structure is still standing. It's not perfect, but you can see that you have to have exact structure planning. Otherwise, it'll end up like this. And if there was an earthquake, like if I shook this table, and I'm shaking it now, it is still standing. But a real building would not be able to buckle as such. It would be straight and standing however they planned it. And that, my friend, is also involves the people who put up the buildings. You have your engineers who plan engineers who plan the structures, how they're going to make the structure stand, how they're going to make the structure resistant to failure, such as caused by earthquakes. And then you have architects who design the idea of the building, and they work with the engineers to get this building produced. And then, of course, you have your construction workers and your iron workers that help with the building. But that interior part, the interior of the structure, is what is going to make or break a building. So that's it for today's tutorial. I hope you all learned something about engineering, and if you have any more questions or are interested in any projects, please visit us at the library here in Carrollton. We would be happy to set you up with some supplies if you don't have any of your own. And we would also be very happy to see anything that you all do. You can post it on our Facebook page or even our Instagram. We love it when you participate and enjoy our videos. So until next time, happy crafting, happy engineering. Thank you. Glad you stayed till the end because we have a bonus segment. Elizabeth is going to shake this cart and see if my structure stands up. Oh no. Oh, it's leaning. Oh, it took about 16 seconds, guys. But that's the thing about engineering. You got to make sure and you got to test what you've built. Thank you, guys.